Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today is Salih Jantakin. Hello, Salih. How are
Hello,
you?
Robert. Thank you. I'm good. How are you?
Great. And today's episode, we're going to talk about working with spans and strings. Now, just to level set, this is not a beginner introduction. It turns out that there are some advanced things that you need to know about these things and probably don't. I expect to learn a lot on this, even though I've been using .NET since it was invented. But Salih is going to show us some things we do know and no doubt some things we don't know about spans and strings. Salih, introduce yourself a little bit so everyone knows who you are.
Hello, I'm Salih Chantekin from the United Kingdom, and I've been working as a software engineer, as a senior. And in 2023, I've been awarded as a Microsoft MVP in development technologies.
Congratulations.
Thank you.
All right. So let's dive in. What is it that I don't know about spans and strings?
You probably would know, but let me just try my best. Strings, and I just need to talk about strings briefly. It's because span actually stands just a bit up strings. So
Okay.
that's why I just need to talk about value types, reference type, and strings, why strings are different, and what span brings into our life. I'm just going to put something over here and say, okay, this is x10, and there will be something else, y, but it's going to be x plus 10. And now I'm going to change x values to 5, and I'll just write down this one. So if I put y here, what would we expect to print it to? So x is 10 in here, and I just said, okay, this is 10 plus 10. And then suddenly I change x to 5. For the value types, so integer is a value type in Visual Studio in C# though. And the second I assign something into it, the value from the right side of the equal is copied over to left side. So after this assignment, no matter what I change x to, actually, if I just put y, it would be 20. And if I have the user for the same situation, let's say I have user 1 with ID 1, and now I defined user 2 with referencing it to U1, so the user 1, and I'm now changing the ID to 2. If I decided to print out this U2 ID, what is expected is actually the same behavior as happened for X and Y for integer, but it's not going to happen. It's because now I am I am assigning the reference. That's why the class is called reference type. So instead of the copying value over, I'm just setting the reference. So U1 and U2 means actually I am reaching the same reference, U1 over here. So this U2 is going to be 2. The ID would be 2. But it is a bit different for strings. So let's say I have string S1, and it is VS. And now I'm defining S2 with S1 plus 2 And I'm now changing S1 with VS underscore maybe. And now I decided to print out S2. So S1 is pointing VS in the heap. And now I am creating a new string. It's because strings are immutable in C#. We are not able to change its value, but we are also we are only able to create new string on the memory side. I'll just show you in a couple of minutes. So if I write that one actually as 2, it's going to be VS 2 bucks. 2 bucks. So we are not able to change the strings. It is because, let me show you how memory works. And I have a screenshot over here. It represents our memory. On the left side, stack side. On the right side, the heap side. We know the value types are all stored on stack, and the reference type goes directly into heap side. So if I create x, integer x10, and the value and the variable itself is going to store on stack, and the boolean again, it's a reference value type. But for the string, as the string is a reference type, the second I created any content, it is not having only pointer on the stack side, but on the heap side, it has a pointer address and its value. So the content goes over here. It is the same for user class as well. So it is now pointing out user class content on the heap side. This is basically how we are keeping our string values on the stack side, the pointer, and the heap side, the value. So now I have a perfect example for this one. This is just AI generated, randomly generated 1,000 rows, random request logs. Every log line starts with datetime and the HTTP verb, if it is going to be post, delete, get, and the HTTP endpoint address. So basically the last part, what page I'm going. And this is the HTTP status code returning. So the page is moved apparently. And this is how the request, how long the request took actually. It says 30 seconds, milliseconds, sorry. It is 211 millisecond for about page, and it is get. Now your boss is asking you parse all that logs, every line, as long as the HTTP method is get. And this is the log model you're gonna need to use. So the duration we are gonna need, HTTP method, and the created date. Those three parts, those three properties I'm going to parse, try to parse. So it seems like a structural data. So we know where the date time is, we know where the HTTP method is, where we even know every part is. So if I ask you, if I ask any developer, how would you basically parse this one? So you would just come to me with a couple of ideas, just like you would use substring method. You would use split method. So basically you can use the space between those parts to just have an array with every part. As it is, there's an expression over here. You could just use regular expression and maybe even more to more performance, maybe compiled regular expression. But I would tell you, I would just give you better and solution with spans. So this is where spans come into our lives, actually. It's because this is how span works, a bit differently. So again, on the left side, we have stack. On the right side, we have heap. Spans basically are reference type of any strings. It is referencing the string, but also little part. So the part of it, I can say. So spans itself is a value type. So it's going to be stored on stack side. It has pointer address and offset value and the length. Let's say we have content and its value is VS Toolbox. If I created new span by using this content, so the content span, basically I would have three different fields. So the pointer, it's pointing A1 VS Toolbox, and the offset meaning that I'm going to get a slice of it. I'm not gonna need the whole string. I'm just going to need a slice of it. And this is going to be offset 6. So I will be starting from 6 and the length is 2. So basically I'm getting B on O. So this is the length. If I use content as span as slice, it is going to be referencing. It is referencing. As I'm referencing, that means I'm not copying over the whole value. It's because I know if I copied all the value, that would mean creating new content on the heap side and new pointer on the stack side. Basically, I'm copying the same value again and again and again. So this was the problem with strings. As it is immutable, as it is immutable, you cannot change its value, but you can create a new one. But the creating new one is a bad example of consuming the memory. So by using,
if you had 1,000 of those, if you just use substring or etc., then you'd be creating 1,000 string variables.
Exactly.
And here using the span, you just have the one, and you're just basically reading from it.
Exactly. This is what I'm going to show you actually. So let's assume and put this one here. So now this is our example of logs, and I am just looping through all the log lines, and the line is the whole line string. So this is the string on the memory. So by only getting the HTTP method, I'm basically going to 20th array in 20th index, and I'm getting the 3 of them. It's because I know I'm just going to need the get values. So the HTTP method get. So I am basically creating new string. I don't know if you just aware of it, but for string methods, let's say string line substring. So it is now creating a new string and give it to you. So almost every string extension function is returning new string. It is not changing the current value. It's because the strings are immutable. So you cannot change, but you can bring new string with that. So it is the same for replace, for example. It is again giving you the new string. So, but it is not the same for span. I'll just talk about in a minute. But over here, basically, I am creating a new memory allocation with 3 bytes. And I'm writing my if condition. If it is different from get, I'll just continue because my boss says so. And over here, I'm now creating new memory allocation. It's because I'm now getting the date str, so the set string of the date version, this data. It is now creating 19 bytes data, another string.
Right.
And over here, so datetime is struct. Basically, I'm not creating any memory allocation. If it was a record or class, I would basically create new one. For that one, I'm not creating a new string allocation for every line, as it is static string. So it is going to be created only once, and the reference will be copied over. And there is nothing on the right-hand side, but let me just grab every argument just to see. So on that line, I'm not creating any allocation. So I'm good. So on that line, I'm not creating again. It's because it returns, it returns an integer value. I'm just basically searching something, space. So just to get the duration index where it started. But now this time I'm starting from the right-hand side. So I'm finding the last space. So no memory allocation. But over here, I have another substring. So this would be yes for me. Now, now I am basically getting this part of it. This is another 2 characters string. This created new memory allocation. So no memory allocation here, no memory allocation. I mean, yes, memory allocation over here. It's not because of the string, but because of the class. So the log model was actually over here as a record, as its a reference type. It stands on the heap side. So this is going to be what happens if I try to parse every line by using substring. Create
now
new allocation.
Does it matter what you call the string? So instead of doing HTTP method, date string, and duration string, if you just had string, my string, it would be the same thing, right? Or could
it would be the same. Yeah, it would be the same actually. It's because creating the part string is this part actually.
Yep.
So if you call substring, that means you're going to create a new allocation on the memory side. And it is almost going to be the same for split, but there's one part. So this one and this one and this one is basically conditionally. So if the HTTP method is get, you're going to create this one. But if it is not get, you're just going to create 3 of them. So 3 byte character, that's all. But for split, you're going to need to use split just before this part. So the second you call this one, it is going to create a new array. So string arrays are just stored on the heap side, we know. So there's a memory allocation, not for 3 characters, but for all the parts. Basically, you are creating a new allocation for every part of this line, split it between space. So no matter after that one, you're continuing or just creating new one. but it is going to create new allocation here. So no allocation here. So no allocation here. So yes, this one is another example of creating new allocation. It's now because we have this part in our array, but I'm just gonna need to get rid of this ms. So the ms part, the last two parts. So now I'm calling replace function, but the replace returns a new part of string. So now I'm creating again different string, and this is going to be the same. And it is for regular expression and compiled regular expression, it is the same. So basically you created memory allocation here. No matter if it is get or not, you're going to use the same value. And over here, this is different. It's because my expression parts the date and the time differently. So I needed to combine them. But again, as those are string, so within here, I'm creating new string, so another memory allocation. And it's going to be the same for compiled regular expression again. But for spans, it's not going to be the same. Let me just show how it works. So again, I just started looping through, and this is not going to create any allocation. It's because span itself is a struct. So it's a value type. It is stored on the stack side, no memory allocation. So this method, slice method, actually, this is where the magic happens. I am basically getting slice of it, maybe, so the box, the BO slice, not creating a new string allocation. I'm basically pointing out by using the reference, the pointer reference here. And what happens here is creating no memory allocation. And I'm still able to check its value without creating a new allocation. I'm basically saying, okay, start from 20 here and get slice of it, 3, and check if it is get. So far, no memory allocation.
And what does slice return there?
And slice return is read-only span. Just over here, we can see read-only span char. So this is, again, struct. So this is, again, it stands on the stack side. So no allocation. Now, basically, I'm using the range operator here. So no memory allocation. It's because read-only span. Over here, no memory allocation. Again, datetime is only struct. So a value type. Again, no memory allocation. So I'm still using this slice method by parsing the duration and no memory allocation again. And no memory allocation here again, but there is something over here. So slice returns read-only span. So this is going to be the same one. But what happens is that, and for string part, substring part, integer parse accept string over here. So as long as it is string, I can pass it to the parse method. But here it says, okay, I also accept read-only span. It is because if you are using slice, what did I say? Just it is basically getting the slice of reference. It is using the offset and the length value. It is not the actual string. But if you're gonna need that part as a string, so if the integer and integer parse function force me to use string, what I would do is actually come over here and say, okay, to string. The second I convert it, to cast it to string, now I create its memory allocation. It's because it is new piece of string right now. But integer parse doesn't force me to use string only, but also it accepts read-only span. So I'm still good, no memory allocation.
Fantastic.
But it is not going to be the same for here, HTTP method. It's because log model forced me to create some new string. So in this part, I'm going to have to create a new memory allocation, but it is going to be the only one I created. So I'm checking my lines. So no, no allocation, no allocation at all, no allocation at all, no allocation again. And this is the only case, but it is because of my function. And I said parse is accepting read-only span char. It is the same for datetime parse. It is not going to ask me to pass, it's a string. So it can accept the read-only span. So if you're working with spans, basically, you're going to need it as read-only span. The second you need a string and you convert it to string by using maybe to string function, this is where you create a new allocation. So it is important to use span, but it is also important that C# itself is giving you to use the span as well by creating this parse exec and integer parse method accepting read-only span parameters. So this is the important part. Briefly, I'm just going to show you the benchmark result that I have just done before that. It is basically showing us, let me zoom in a bit. It is basically showing us how much memory we are creating by parsing the very request log file, the same logs actually. And for span, I am creating 16.88 kilobytes, basically 17 kilobytes.
Yeah.
But for substring, basically, I'm creating almost 4 times, so 64 kilobytes.
Yeah.
It is because there is some part of it, three lines, and the rest was conditional. So I didn't have to create all for all. But it was not the same for string, if you remember. I had to split every part and put it in a string array, which creates a memory allocation. I can see how big it is. It is 352 kilobytes. And for regular expression, it is going to be the same. It is going to create every bit, and it is going to get every part of it. And plus, Regex has its own property to manage every possible match. So it creates even more allocation. It's over 1 megabyte, so 31 kilobytes. So we basically did the same thing by using different sort of parsing techniques, regular expressions, splitting, substring. But the span was the most efficient one, not only for memory allocation, but only the performance. So it is going to take only 93, it is microsecond, 93 microsecond. If you're going to work with regular expression, it is going to be over 1,166.
Right.
So this is the benefit of using spans while you're working with strings.
That's awesome. So I think I will admit to using strings way more often than spans. So I will change. That's awesome. So here's the silly question. When were spans introduced? Have they been in there since day one? Is it a recent feature?
It is not a recent feature. I believe it is introduced with .NET 5.
Yeah.
But as I just said, span is just starting point. So the .NET itself is giving you ability to pass it through. So, and every new .NET version brings new using strings and spans. So every version, their Microsoft crew is using span behind the scene. So this is maybe the reason that it is going to speed up.
Yep. That is fantastic. Wow. Thanks so much for sharing that with us. That's really good to know. It's really good to know.
Have you learned something that you didn't know?
I learned something that I didn't know enough about. Yes, absolutely.
I tried my best, as I said.
You were. That was great. Thanks so much. Hope you guys enjoyed that, and we will see you next time on Visual Studio Toolbox.